Hello everyone. I know a lot of you are taking APs this week, so we're going to be going a little lighter and doing something nice and straightforward. That something is expanding binomial powers. Now, you've done this before. If you had AB squared, that's a plus b times a plus b. So a squared plus 2ab plus b squared. If you had ab cubed, you can multiply that by a plus b. So it's a cubed plus 3a squared b plus 3ab squared plus b cubed. And you can continue that pattern forever and ever. Now, unfortunately, for something like a plus b to the sixth, doing it out this far, like doing this times itself, which is what that would be, is kind of a pain. It's a little bit harder, a lot more labor intensive. So we're going to learn a shortcut to do this. We're going to learn, a couple of shortcuts in order to expand the power of these binomials. All right. So it all starts with our basics, our lowest powers. If you have a plus b to the 0, that's just 1. So the only coefficient is a 1. If you have a plus b to the first, that's a plus b. So a coefficient of 1 and a coefficient of 1. If you have a plus b to the second, a squared plus 2ab plus b squared. So coefficient of 1, coefficient of 2, coefficient of 1. A plus b to the third, a cubed plus 3a squared b plus 3ab squared plus b cubed. 1, 3, 3, 1. And if you keep going, a plus b to the fourth, and I'm going to stop after this one, and we're going to continue the triangle from there. But it's a to the fourth plus 4, a to the third b, plus 6, a squared b squared, plus 4, ab to the third, plus b to the fourth. So 1, 4, 6, 4, 1. So this, starting with what we call row 0, and then row 1, 2, 3, 4, so on and so forth. This, what's happening is, imagine this triangle was in a field of zeros. If you take the 2 above one of the terms and add them together, it gives you that term. Like this one, it's 0 and 1, 1. Obviously starting with that initial 1. 0 and 1, 1. So all of the outsides would be 1. And if we do the same thing here, 1 and 4, 5, 4 and 6, 10, 6 and 4, 10, 4 and 1, 5. And then 1 and 5, 6, 5 and 10, 15, 10, 10, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. And it can keep going and going and going. This is called Pascal's triangle. And you can have an infinite number of rows. You just keep going forever and ever and ever. This is Pascal's triangle. That can help you find out the coefficients of a power of a binomial. Whatever power is on the binomial, you look at that row, starting with row 0. And then these will give you the coefficients. But that doesn't give you everything about the polynomial. No, because there's still the a's and b's in there. that follows a pattern as well. If you had a plus b to the 7th, well, the 7th row, it was 1, 7, 21, 35, 35, 21, 7, and 1. All right, so those were our coefficients. Now, each of these terms is going to have an a and a b. A, B, 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 and A, B. Now, the power on your A is going to start with your highest power, so it will be 7, and it will count down. So 7, 6, 5, 4, 3, 2, 1, and 0. The power on your B will start with your lowest power, which is 0, and count up. 0, 1, 2, 3, 4, 5, 6, 7. The sum of these powers should always be the power on your binomial. And now it's just simplifying. It's just a matter of simplifying your expression. So it's a to the 7th plus 7 a to the 6th b plus 21 a to the 5th b squared plus 35 a to the 4th b cubed plus 35 a to the 3rd b to the 4th plus 21 a squared b to the 5th plus 7 ab to the 6th plus b to the 7th. There you go. That's the expansion of that binomial. And this works for any binomial being raised to a power. Let's say we had, I'm not going to do crazy coefficients because I don't feel like pulling out my calculator. Let's say we had 2x minus y to the 6th. So since it's to the 6th, our coefficients will be 1, 6, 15, 20, 15, 6, and 1. And we'll have a 2x on each of those. Two x, 2x, 2x, 2x. And the powers on the 2x, we'll start at the top and count down. So 6, 5, 4, 3, 2, 1, 0. And then we'll also have the negative y. Negative y to the 0, negative y to the 1, negative y to the 2, negative y to the 3, negative y to the 4, to the 5, and to the 6th. And evaluating that will give us our endgame. So 2 to the 6th is 64. So it's 64x to the 6th, negative y, so negative, and then 32 times 6 is 64 times 3, so that's 192, x to the 5th, y to the 1st. Negative squared is positive, so it's going to be plus. 2 to the 4th is 16. 240. I don't need that. So 240 x to the 4th, y squared. Negative cubed is negative. 2 to the 3rd is 8 times 20. It's 160 x cubed, y cubed. 4 times 15 is 60. Negative to the 4th is positive. So plus 60 x squared y to the fourth. And then 2 times 6 is 12. Y to the negative to the fifth power is negative. So it's negative 12x y to the fifth. And then plus y to the sixth. So that's the full expansion of that. Didn't have to distribute through anything. Just setting it up and multiplying based on Pascal's triangle. All right. So that's binomial expansion using Pascal's triangle. Have fun.